So in example 7, we want to write 8/3 as an equivalent fraction with a denominator of 12. Okay, so let's see how this flows. Okay, so we have 8/3. Okay, but this is the same as 8/3 times 1. Okay, so we just want to multiply by 1, but we want to multiply by 1 in a form so that the denominator becomes 12. So in other words, what do you multiply the 3 by in order to get 12? 4. So we're going to multiply by 1 in the form of 4/4. Notice that 4 divided by 4 is 1. So it doesn't change it. It just gives an equivalent expression or equivalent fraction. So then ultimately we get 32/12. Okay. So we'll see why we're doing that momentarily. So let's just keep going. So in example 8, it says write the rational expression. Write the rational expression as an equivalent expression with denominator uh, 12x squared plus 8x. So the expression in question, we want to rewrite 3x squared plus 2x is our denominator, and the numerator is 7. So we want to rewrite this with the denominator of 12x squared plus 8x. Okay. So the suggestion here, so we want a denominator of 12x squared plus 8x. Let's write, can we factor this denominator? Let's see. Let's factor this 12x squared plus 8x first. So if we factor the 12x squared plus 8x, that's the same as, what can we factor out of 12 and 8? 4. So then 4, and we can factor out of what? X. And that leaves us with 3x plus 2. Okay. So then let's factor our denominator. So we have 3x squared plus 2x. We can factor out an x. So then we have x times 3x plus 2. Okay. So essentially these are the same. The only difference is we need to multiply the blue one. We need to multiply it by 4. And this parentheses is not a 6. It's just a ill-drawn parenthesis. Okay. So we need to rewrite this. And so basically we need to multiply the top and bottom by 4. So then we should get this denominator. So I'm going to copy this. So we have our fraction and we said we're going to multiply the top and bottom. So we're going to multiply by 1 in the form of 4/4. Okay. So I'm going to go ahead and do the denominator. What do we have to do with this 4 and this term, in these terms? So we really have it like this, so we need to do what? Distribute. Okay. So the denominator, 4 times 3 is going to be 12x squared plus 8x. So we got our desired denominator, and the numerator becomes what? 28. So then it should be this. Okay. So let's look at some steps to forming an equivalent rational expression. Okay. So we wrote each denominator in factor form. We did that. Determine the missing factors, that is, what factor or factors does the new denominator have that is missing from the original denominator. In our previous example, what was missing was the green 4. So notice that when we factor both the denominators, they were essentially the same, but we needed the 4. So we needed to introduce the 4. Okay. Multiply the original rational expression by 1, but that 1 needs to be in the form of the missing factor or factors over the missing factor and factors. In our last case, we multiply by 1 in the form of 4 over 4 right here. The missing factor was 4, so we multiply it by 4 over 4. And then we find the product and leave the denominator in factored form. Now, I don't think we left our denominator in factored form in the last one, but but that's okay. So generally, you leave the denominator in factored form. So let's try another one. So this will be example 9. Find the LCD of the rational expressions then rewrite each rational expression with the LCD. So we want to find the LCD of the rational expressions, then rewrite each rational expression with the LCD. Okay, so let's see what are the rational expressions. Let's give ourselves some space. Okay. So the first rational expression, the denominator is x squared minus x minus 6. The numerator is 3. Second rational expression, denominator is x squared minus 9. The numerator is 5. Okay. So it says first find the LCD of the rational expressions. So we need to factor all the denominators. So we have x squared minus x minus 6. What does this factor into? So we have x and x. Tell me about the signs. They're different, so one's positive, one's negative. This tells me that the larger one is negative. What are the two numbers? 2 and 3, so then 3 and 2. 3 times 2 is negative 6. 3 plus a negative 2 plus a negative 3 is a negative 1. Let's factor this x squared minus 9. What's the result there? So we said x squared minus 9. So then it's what? X minus 3 and x plus 3? Okay. So we only want to use one of these x plus 3's. Okay. So then the LCD is going to be x plus 2, x minus 3, and x plus 3. Okay. So 3 and 5. Okay, so the first one was 3 over x plus 2 times x minus 3. Okay, so the only thing we're missing is the x plus 3, so we multiply the top and bottom by x plus 3. The second one was, the denominator was x minus 3, x plus 3. The numerator was 5, so we were missing the x plus 2, so we multiply the top and bottom by x plus 2. Okay. So then you can have something like 3 times x plus 3 over x plus 2, x minus 3, x plus 3 for the first term, and the second term is going to be 5 times x plus 2, and the denominator is the same, so x plus 2, x minus 3, and x plus 3. Okay, so I can write it in this order because you can use the commutative law of multiplication. So even though the order is a little different than here, it means the same thing because you have the commutative law of multiplication. So these should be our results. And to take it a step further, you would distribute here. You would get 3x plus 9 and 5x plus 10. But otherwise, it's okay.